Testing. Okay. Well, welcome everybody to the September meeting of the Fort Worth Astronomical Society. I want to give a big thank you right now to our second traveling astronomer, Chris Malicki, who literally got back this afternoon from the Big Island, and he's here to help us get our meeting transmitted over the internet. So thank you very much. We're running just a tad behind, but thank you very, very much. I believe we have some visitors today, don't we? If you would raise your hand so we can get some introductions done. There's at least 3. 4. Nick, go ahead and start it off. Go ahead. No pressure.
Okay, well, hello. My name's Eric Nickler. I'm from here in Fort Worth, actually up here in Hazlet. Really just got into astronomy, bought my first, second telescope about 6 months ago. Well, my first, 7 months ago, and my next one, right after that. So, getting into it, I've got a 6-inch Smithsonian. Pretty much just viewing the planets so far, but it's been great. So we'll come by and see what you guys are all about. So thank you for having me.
Thanks for coming. And as you figured out, astronomy is addictive. As you figured out, if you have 2 scopes now, astronomy is addictive, but it's legal. Yeah. Stephanie, welcome. Welcome. We're glad to have you. Yes, sir. Well, welcome. We hope you join us because you're a camper and an astronomer. We have a place for you.
Oh, yeah, big time.
So, welcome. There was this young fellow back here.
I'm Kevin Miller. I'm from Mansfield, and I've known Constantine for over 30 years. He joined and said, hey, you should come. I think I bought my first telescope in 94. It was a small 90-millimeter refractor. I bought my second telescope in, 98. It's an 8-inch reflector. And I just bought my third telescope about a month ago. It's a LX85, the advanced cone free 8-inch electrode as well.
Nice.
But I still consider myself a novice, so I can't see what I learned.
Well, hey, we're all learning. Awesome. Yes, sir.
I'm Corey. Actually live with in Denton. With the club there, so I'm down here. And I actually go to TCC, and I'm taking astronomy this semester, taking stars and galaxies. So there's quite a lot of learning in there. And also we get extra credit for coming to something like this.
Well, hey, we provide all kinds of assistance, and we're glad you're here. Yeah. So we're glad you're here. As you'll see, we're a good group of people, and I'll get into a couple of more details just in a moment. But most importantly, every opportunity I get to talk about Big Bad John, please see John about joining the club. And John is the young man at the far back there in the corner with the red shirt, and that's his seat. So anyway, again, welcome. And we have some new members. Hassan, are you here today? was emailing with him today, and he thought he might be able to make it. The Mayberry family, are you all here? The Paul family? Okay, well, welcome, and thanks for joining. And the Lorenzino family? Lorenzo.
Yeah, my wife's working.
Okay, I'm sorry. With a name like mine, I do try to pronounce everybody's name correctly. Well, welcome all the new members and the visitors. So I will just introduce you to the club real quickly. We were founded in 1949. It's a little more than 70 years ago, if my math is right. One of the oldest and largest astronomy clubs in the country. Right now we have 179 or 180 members. We kind of have a peak. So last year at the end of the club we had over 200, and we're well on our way to gather more members. So we have a huge range of experience. We have terrestrial observers. These are folks who just look at the sky. We have radio astronomers. We have folks that just do observing, like our former president, Michelle Thiessen. And we have imagers and just about everything in between. So lots of differing subgroups, and we all like to talk, and we all like to chit-chat about astronomy and all that other good stuff. Let's see, and keep in mind, this is one of my maxims. The only dumb question is the question you don't ask. So please, if you have a question, ask us. You can ask here. We have an e-group. There's all kinds of ways to get information. And our club's nonprofit, so we're always looking for donations. And that's another John Giormini task. Okay, so the executive board, a lot of folks, my name is Bob Sirkis, I'm the president. Bill Hall, who's going to present twice tonight's vice president. John Giormini in the back there in the back, far corner back there is our treasurer. Monica Merritt, who is online, is our secretary. And Jim Potts is a director and the associate treasurer. He is soon, eventually, to assume the role of treasurer. Ted Smith is another director. Bruce Campbell is a director, and he's a key guy when it comes to Rising Star. And Cy Simonson has two roles with us. He's back there. He is a director, and he's our legal beagle. So when you hear me say legal beagle, I'm talking about him. Okay, so we have some key content information here. I'm just going to go through the committees. So we have a development committee that helps build out the plans for the Rising Star observing area. Michelle Thiessen is the lead of that committee. We have public outreach. That's Patrick McMahon, who's in the back. That's what we do a lot. And it's awesome. If you haven't done a star party, you need to. It's an awesome experience. And then John McCrae, who's not here today, takes care of Tandy Hills. That's a partnership we have with that group. And he runs the monthly star party out there. Pam Klopfer is going to report for him later. We are working on a permanent connection with the Thompson Observatory. This is not the old Thompson facility. This is the Thompson Observatory at the Southwest Adventist University. We have a fixed Saturday, the fourth Saturday of the month, where we can go out there and use the facility. And we also help them get things organized. George Lutch and I are going to help rebuild their Paramount Mount when a board gets in there, for example. George Lutch takes care of Prime Focus magazine and the website. We're in the process of migrating from our current host to Google. And Bill Hall is the master of this presentation. He puts this all together, and I'm telling you, it's a huge job. So if you have any feedback, you pass it to Bill and myself, or you need. Yeah, if you want to present, that's the biggest challenge of the vice president. And then John takes care of memberships and donations. Pardon? Oh, okay. And we have two guys on the Eclipse Committee, and Juan, I believe, is going to talk to us later. Juan Martinez in the back, and Chris Malicki. And Bill Hall's having a stroke. So tonight, Bill Hall is going to present on observing the sun, an in-depth review to demystify the gear available and how it works. Take it away, Bill. And I need to really clarify that the raffle is anything this way. Thank you.
Thank you, Bob. I really, really appreciate that. So, we have a theme going into next month and on into next year in April, and it's about the sun. And just like comets, you get comet fever when a big, bright, naked-eye comet comes into the sky. We've got solar fever, eclipse fever. The end. Thank you. Good night. No worries. No worries. Spoiler alert. Oh, bless. Well, you're going to see the next slide. You know, if you've any. Yeah, this is totality right here. Yeah, this is actually the corona is way out here. It's bigger than the screen, so this is just the moon part. All right. Wow, you really, okay. A power issue? So anyway, on any telescope or binoculars, you're going to be seeing these warning stickers. Don't look at the sun through the telescope. You're not supposed to look at the sun, okay? You're in a space club. You probably know that by now, okay? So solar retinopathy is sort of what you get when you look at the sun, and this is what it looks like when you suffer from that. So it's a pretty big deal, and it's not necessarily just stupidity, but it could just be that you're not thinking while you're doing what we do when we're looking at the sun. Next slide. So there are instruments that are meant to safely look at the sun, and it astounds me just putting this presentation together, looking at some of the things that people, you know, do, looking through processed negative film, whatever this is. and looking through CDs, looking at a reflection in your phone. It's just all sorts of cockamamie stuff. What I'm going to talk about tonight is the way to do it right and the way to do it safely. And next slide. Don't ever look at the sun. I don't care who you are. It's dumb. Next slide. So there are other safety considerations. This isn't just about looking at the sun, but there's about protecting yourself, sunscreen. Got a towel here that I actually put over my head when I'm looking through the eyepiece, and that protects this dome from getting red. With the telescope, there's a lot of heat that is coming from the sun, and when you take a telescope that's got mirrors in it, that mirror down at the bottom, like in a Dobsonian, any sort of Newtonian scope, that secondary mirror up at the top, I guess it's up at the top, sorry, the secondary mirror, the smaller mirror up at the top, is getting a lot of light focused on it. It'll crack. So you got to watch out for that sort of thing. There is something called energy rejection filter, and we'll get to that later. But mirror optics are really something. There is only one occasion where you really use for solar astronomy, and we'll get into that. The other thing, we're going to cover etalons. Etalons are the high-end filters to use to see the hydrogen line in the sun. And with solid etalons, that having a UV IR cut filter or an ERF, the ERF, energy reflection filter, actually buys time. It lengthens the life of your solar filter. So we'll get to what an etalon is later. So this is what rain looks like on the sun. This is a time lapse. This is a time lapse movie made by Alexander Hart. She's an amateur out of England, and what we're basically looking at here is a time lapse of plasma basically going up into the upper chromosphere and then cooling and raining back down, succumbing to the sun's gravity. And although this is a time lapse, to sit and watch the sun, you can spend time looking at it and watch it change in real time. It's a very cool thing, and it makes it very dynamic sport that you really don't get with looking at other things in the scope. Next slide. So, what's really going on when it comes to what we're seeing coming out of, looking through a telescope, looking at the sun? So, a photon comes from the surface. It's been traveling 10 to 100,000 years through the middle of the sun, coming out from the surface and gets absorbed by an element in the solar atmosphere. Okay? So that absorbing energy that atom is doing causes an electron to jump up to a higher level. It's energizing, it's absorbing the energy, okay? So when that atom settles again and goes back to the neutral state, it releases that energy in the form of a photon, which is a light particle. And that's how light's born, with an ionized particle. That's why ionized particles glow. It's actually not the ionization, but it's the release of the energy after the ionization that makes the light. So the thing is that odds are in probability that the photon will not continue in the same path that it went when it got absorbed by the atom. It's going in a different direction. What that does is it creates darker lines in the spectrum of light, and those are called absorption lines. So now you know what absorption lines really mean, if you didn't know that. It's basically atoms absorbing the light and ejecting the photon at a different direction. So what we're looking at through filters is the transmission of the filter centered on the absorption line. Okay? Clear as mud? Next slide. Okay, so this is the sun through 3 different filters. So this first one right here is white light. So it's been colorized. You actually look through a white light filter at the sun. Actually, when you look at the sun is emitting white light. It's a yellow dwarf, but it's emitting light that's rather close to what we call white. And so this is colorized yellow to make it look like a sun. But what you're looking at with a white light filter, go ahead in the next slide. What you're looking at with the white light filter is you're looking at the photosphere. So we're talking about the surface of the sun. So what they're calling the photosphere is the light that's being emitted from the sun. And you've got sunspots, and you've got solar granulation, which is basically the top of the convection that's coming up from the core of the sun. Next slide. So this is the calcium K line. The K line is, it's one of the absorption lines in the spectrum that represents one of the places where calcium resides. So what you're seeing is you're seeing slightly higher elevation than the photosphere. Kind of into the upper photosphere, into the mesosphere a little bit. We'll get into that in a second. But you can still see sunspots, but you can also see this feature, these white patches right here that are a little bit higher than the elevation of the photosphere, called plage. You're starting to see the chromospheric network, which is the lower part of the chromosphere here. You're getting features that are basically in the layer of the solar atmosphere that's right above the surface. Okay, next slide. So here we're talking about hydrogen alpha. This is the holy grail of solar observation. And you see the sunspots, you see the plage, but you really start seeing what's happening in the lower to upper chromosphere. So you've got, and this will be explained in a little bit as to why we're seeing these, but you're really seeing the action that's going on, which is the hydrogen alpha line in the solar spectrum, that when hydrogen is releasing its photons, this is a sort of activity that's going on in the chromosphere. So the chromosphere is the layer right above the mesosphere, and let's go to the next slide here. So I put this together. This is not a thing that you can download on the internet here. I had to put this together because the information was actually quite all over the place. And I don't know about you, but to say, hey, wow, man, it's like 300 degrees Kelvin outside, man, it's pretty hot, it doesn't mean anything. So what I did was I converted it to Fahrenheit, so that we could all get a little better gauge, since we're Americans and don't mess with Celsius like Fahrenheit. We also took kilometers, and I changed them to miles. So photosphere right here, we're talking basically fundamentally the surface of the sun, the top of the convection flow, which is called granulation. And then the cooler displays of sunspots sunspots aren't really as dark as that. They only look dark because of the contrast between this bright exterior of the sunspot. And the sunspot, you're really not seeing some sort of depression in the surface. Basically, the gas that's above the sunspot just happens by nature of what's going on with the magnetic field to actually be more transparent. So you're actually seeing into the sun when you look at a sunspot. About 300 miles up from the mesosphere or 300 miles up from the photosphere is the mesosphere. You're starting to see those easily ionized elements. So like calcium, iron, titanium, magnesium. Hydrogen and helium at this point still stay neutral, okay? Magnetism of the sun forcing this matter upwards. 600 miles, your temperature starts out at about 10,000 degrees Fahrenheit on the surface of the photosphere, comes down a little bit, and then goes up a little bit in the chromosphere. So 600 miles from the surface, you've got magnetism entirely filling this whole layer here. The magnetic network develops, so you're starting to see things flow laterally. Hydrogen and helium begin to ionize here. Fibrils stream outward with the magnetic force. So the magnetic network is actually starting to spread matter out laterally. Fibrils is basically the top of those plage things. It's basically hot spots, bright spots. So you get a little bit higher at about 1,800 miles, and you're looking at what they call the transition zone. So the temperature goes up about 4,000 degrees Fahrenheit. It's continuing to be propelled upward with magnetic forces. You're seeing a lot of the extra stuff that's in the chromosphere that you see through a hydrogen alpha filter. You're seeing the bigger features, the things that are starting to extend from the chromosphere towards the corona. So at about 6,200 miles above the photosphere is the corona. And this is the big mystery. One of the big mysteries about the sun is that it shoots from the upper chromosphere of 14,000 Fahrenheit to 1.8 to 3.6 million degrees Fahrenheit, and nobody knows why. It's an absolutely fascinating thing about the sun. Nobody can figure out. Condensation of cooling ionized gas rains down like we saw before. Anything that gets ejected out is going to be solar wind and mass ejection. What does C stand for? Coronal mass ejection. Thank you. So what you see over here on the left is during like a total eclipse with the naked eye, you're seeing just the edge of the upper chromosphere, where the prominences are, and you're seeing the corona. So down here in white light, you're looking at the photosphere. If you want to look through a calcium K line or a magnesium lowercase k line, it's basically looking at the mesosphere and the chromosphere. Hydrogen alpha is looking pretty much entirely in the chromosphere. If you adjust the wings of the etalon, and I'll explain that in a little while, you're able to see lower into the photosphere. So that you'll be able to visually see this later. But each one of these filters gives you a different layer, a different altitude of the solar atmosphere. So they all play a part in being able to kind of see a fuller picture of what's going on above the surface of the sun. Next slide. But seeing is everything. It's not like nighttime scopes where you want to get the biggest aperture possible. The problem that we fight with the sun is that it's heating the atmosphere, and it's up, and the atmosphere is just churning during the daytime. And so you get what's going on in the background here. This is basically a close-up of a couple of sunspots with the effects of seeing on it. Next slide. So this is the listing of all the things that you can do to beat seeing when it comes to solar astronomy. Smaller aperture, basically there's a, you can gauge that, smaller aperture, if your seeing is bad, that a smaller aperture settles down what you're seeing as far as seeing problems through the telescope. When seeing is spectacularly good, or you happen to live on an island or in the French Alps or something, then you can get a really big aperture, or space. Lowering your magnification does the trick. Higher elevations, they've actually determined that just 6 feet off the ground, you actually get better seeing, because there is a layer of turbulence that's actually happening on the ground that actually affects your telescope. Setting up at the edge of a body of water, because there's cooler air that's coming off of the water. Setting up and looking at the sun in the morning when it's cooler. The sun hasn't had a chance to heat up the atmosphere. So we're kind of beating the heat, if you will. There's kind of a other side of that, is that when you've got the sun at a higher altitude, you get the same benefit as any object that you're looking at in the nighttime with a higher altitude. You're not looking through so much of the Earth's atmosphere. So when you're looking straight up, you're looking at the thinnest part of the, you're not looking obliquely through the atmosphere. So it's sort of that sort of balance between starting the morning when the sun is low and trying to see it at a higher altitude. It's always just a trick, and local seeing is just what it is. So, these are workarounds however you can. Presence of light cirrus clouds. Now, I've not heard this one before until I made this presentation, but it does make sense. Light cirrus clouds can actually, I don't know. I have no idea what that one's all about. There wasn't really a lot of explanation for it, but I put it in. So just trust. Telescope optics at ambient. So putting the telescope out, getting it to temperature. If you've got a contrasting temperature inside your telescope than what's outside, you're going to be dealing with what we call internal seeing. Or if it's hotter on the inside than it is on the outside, and you don't have the inside of the telescope cooled off like it's been, the sun's I don't even know what sort of scenario that would be, but basically, if you've, one of the tricks here is to make sure that the inside and the outside ambient temperature are the same, so they're not fighting each other. Getting away from heat-retaining surfaces, so rooftops, concrete. If you be next to a body of water or at an elevation, then something in a grass field or something like that out in the country, it's always going to be your benefit. The sun's going to heat up roofs, it's going to heat up concrete, it's going to do that thing, and as the day goes on, it just gets worse and worse. Next slide. All right, so what we're going to do is we're going to take a journey from sidewalk chalk to laser printer. So this is basically the simplest, easiest, cheapest, most accessible ways to look at the sun, and then we're going to go to the other end. So next slide. All right, so we start off with pinhole projection. Okay, so we've got a pinhole in paper. When in 1979, I was in 2nd grade, I think, and I was the only kid in the class that was like, you poke a hole in the paper. I knew that back then. I was in 2nd grade. Poked a hole in the paper, and we watched the partial eclipse as it was right there. And I was like, oh God, I'm gonna be old. 2017? Oh my, it's like a million years from now, I'm gonna be an old man. Yeah, anyway. Colander, super fun. You know, when I was at Madras in Oregon for the 2017 eclipse, I was at Lowell Observatory's event up there, just a little north of Bend, and somebody brought a colander, and it was like, what is he doing with a colander? It's just not really the time and place to be making pasta. What's going on? And he pulled it out, and like, it was a million little crescents. It's basically the pinhole projection with just a lot of them. And then, of course, there's soda cracker. Next slide. So, practically no cost, super accessible, it's fun and interactive, and you got a snack afterwards, so a little bonus there. All right, so next slide. So the next step up is solar eyewear. So we got our paper glasses, which Mr. Juan Martinez has so graciously provided. Plastic glasses, which is a similar, a little more permanent thing. And then you got the welding mask. Next slide. So what I talk about here in this whole presentation, the yellow is basically talking about cost. The green things are the pros, and the red things are the cons. So these glasses, they're tinted, so you can look orange or it can look white when you look at the sun. But this is a white light filter. This is basically, it's a higher end than Mylar film, but you can think of it as Mylar. It's not Mylar. It's a special film. But the problem is it can get scratched. It can get pinholes, so you got to really watch out for that stuff. The good thing is that it's free or really cheap. It's free if you know one, and it's just really accessible thing. For about $20, you can get glasses that are actually dedicated. You know, the downside is that they can be scratched, and you can only use them for the sun. Of course, you know, a lot of these things that you can only use for the sun. So, now if you want to drop a little bit more coin, you can get the welding helmet. There are people that do it. As a matter of fact, the welding industry actually suffers supply chain issue a little bit during solar eclipses because people actually go and get number 14 glass welding helmets. It's a little creepy. It's not exactly normal, and you might be challenged to a joust. So there's lots of risk with this approach. Next slide. All right, so the next step up is solar binoculars. One of the things that I will attest to is that Celestron actually makes a line of products called Eclipse Smart. Eclipse Smart. And they're fantastic. They actually make bigger ones than this, and I didn't know that at the time that I bought it, dang it. But they have a whole line of stuff, and it's really fantastic. It's well engineered, it's fantastic stuff. Celestron, Lunt, which we'll talk about later, Meade, and even Canon make these kind of binoculars. Next slide. So these binoculars are dedicated to solar. You can't use them for regular viewing, and you wouldn't want to have that option anyway, so as not to confuse what when you're looking at the sun. Some of them have an orange tint, some of them don't. The Eclipse Smart line is basically white light. That actually literally isn't tinted, so it looks white. The reason why that you see the sun in yellow or the sun in orange or even red is because that's what the sun looks like when we can look at it, which is when we're looking through all that Earth's atmosphere during a sunset or a sunrise. So that's why there's always this color on the sun, because when people can see it, that's what they see. But it's really a white star. So these range from $40 to $125, It's depending on the size, just like any optic. There's different apertures and magnifications. It's white light only. You don't do a swappable eyepiece with this. This is just a dedicated set of binoculars. So, next slide. So, eyepiece projection and white light. So, there's this little doodad called the sun spotter. There's something called the sun gun, which is another homemade thing. There's something Cy Simonson actually brought, thank you very much, is the sun funnel. It's another homemade doodad. And by the way, he's actually, thank you for doing this. He actually printed out copies of how to build a sun funnel. So kind of a neat thing. If you want to grab one of those, you can. Homemade, mounted on the telescope. So this is basically projection through the eyepiece. All these are projection through the eyepiece. And it's basically projecting onto a screen that's basically on a bracket. Juan Martinez actually has a rig like that. And then there's projection to easel. So next slide. So you've got that little sun spotter. This is a spendy little item. It's cute, but it's really expensive. And I don't really understand why, but it's just, I don't know. Maybe it's the novelty of it. These homemade jobs down here, the Costa bowl or the cone, the screen, and the solar film is basically what you're looking at. You can use your regular night scope as long as it's a, when you're talking about eyepiece projection, you're talking about refractors. So with these, where it's actually projecting on a surface, so basically your screen, it's actually projecting on here from the back. So the eyepiece is connected to the eyepiece, and you're actually seeing the solar projection right here. And that is probably the lowest risk when you're talking about something involving the public, little kids or anything like that. It's just like safety's a real big deal, and stray light's a big deal. Homemade mounted on the telescope, you've got the aperture limitation, requires a mounting solution. Wind could be an issue. I don't know if you really get a wind thing when your screen might be small. But it's highly visible, just like the sun funnel and the sun gun here. You got a bigger scope. This guy right here, it's like, oh gosh, that's a Newtonian. And it's like, that one kind of raised my eyebrow here, because it's like, okay, what has he got that's protecting that mirror? And the interesting thing is that when we had our open house at Rising Star, Juan, you had a Newtonian. Weren't you doing projection with a Newtonian? Yeah, it was a very small Newtonian. And I don't know, did you actually kind of feel the temperature of the secondary mirror? Yeah. How did that secondary mirror feel while it? Huh? Excellent. Okay. So aperture is definitely a consideration there, and you've got an easel set up that wind could be an issue. So, but these are really great options when you're talking about something for outreach, just because of their visibility. Next slide. Okay. So then basically you come to this white light filter that basically you can use for any telescope, no matter what size or what kind of scope, mirrors, refractor, it does not matter. If you put a white light filter attached to the front of your scope, you have protected it from whatever sort of light is going in there. It's a pretty serious filter. I've actually got some, if you want to look at this later, this one's by Bada, and it's that mylar looking stuff. It's basically a very, very lightweight film. So it's got a few different options here. You've got Mead and Thousand Oaks are kind of known for making the glass ones. Then you've got Bada Astrosolar film, which I was talking about, and you can buy it in a little package, which is just raw sheets, and the sheets come in much bigger sizes as well. Or you can actually buy it that's already in a mount, in a ring, and you can see how it's actually mounted on the front of the scope here. And if you guys have a Newtonian and you've got this cap on the front, and you've ever wondered why there's this cap, a little cap inside of it, well, that's called an aperture mask. So basically, that's something to look at the sun with if you've got a white light filter on it, or to look at the moon. You're basically reducing your aperture, and you're reducing the amount of light that's going into your telescope. So next slide. So like I said, the glass ones, they're a little spendier, $80 to $300, depending on the size. They're durable. It comes in a frame, and it's got a robust connection, as you can see with these little thumb screws here, which you kind of want. You don't want that coming off of your scope while you're looking at the sun. That's problematic. You got to buy to the size needed. It's not sort of an adjustable thing there. And the glass is breakable. As far as the Bada film is concerned, $40 will get you a letter-sized piece. It's trimmable to size. It's much cheaper than glass, but just like the white light filter film that's in the glasses here, you got to check for pinholes, you got to check for scratches, you got to check for any damage. You can spend a little bit more, up to $135 according to the size that you need. It's actually, each one of them is adjustable. You can see this little screw here can extend out to be a little bit adjustable. Scratchable, and you can get pinholes in it. But the thing is that if you take care with using a white light filter, this solar film, this is really good stuff. You just gotta slow your roll and mind your safety aspect about it. Next slide. Then we get into the Herschel wedges. So these are the three different brands that are pretty popular for the Herschel wedges. There's Antlia, there's Bada, and there's Lunt. Next slide. So the deal about these is you can use your night scope. You're really limited to using a refractor, okay? You can't use one of these in conjunction with a white light solar film on the front. It's just too much blockage, okay? Antlia and the Lunt ones run about $350. The Bada one, like everything by Bada, is like extremely expensive, but you know, there's a thing about the coatings on Bada's glass, and that increases contrast. And in solar observing, contrast is king, and I'll go into that a little bit later. So white light only, it's for use with refractors. Remember the thing about the mirrors. And then it requires no filter for visual, except, no, I'm sorry, it requires, wow, I'm an idiot. It requires okay, forget what I just said there. It requires a neutral density filter for visual. Wow. And it forces considerations on larger apertures. So next slide. And what I mean about forces considerations on larger apertures is that when you get to a refractor that's more than 150 millimeters, it is said it's collecting too much heat, and it's just highly recommended for the sake of the telescope, for the sake of the filter at the other end, that if you're not putting the white light solar film on the front of it, then apertures larger than 150 millimeters should have an energy rejection filter on the front of it. And this is a very heavy duty, it's It's centered broadband around the hydrogen alpha, so it's red, and the light that comes out of it is going to be red. And but it does a serious cut down when it comes to the heat that goes into your telescope with the big refractors. There's also the concern that if you've got oil-spaced elements between your glass and your objective lens, that you could have yourself a little fish fry going on with the oil inside of it. And basically, if you have a concern about that you want to reach out to the manufacturer to find out what they think about it. Next slide. So this is how Herschel wedges work. This is actually pretty cool here. So 100% of the light goes in, and this special diagonal mirror right here basically transmits 95% of the light and the heat, and 5% goes up to the eyepiece. Now, like I said before, if you're using one of these for visual, 5% is a lot of light. 5% of the sun is a lot of light. So you want to get, I recommend actually a variable polarized neutral density filter. These you can actually turn them, and they can get brighter and darker as you turn them. It's really great for the moon. It's also great for the Herschel wedge. This is an Orion one. They run about $60. Next slide. Standard optics conversion to white light in an eyepiece. So basically this is basically just a summation of what I've been talking about. They do have Orion. Is this Orion? Yeah, Orion. They actually sell these big binoculars that have these the glass caps on it, where you can actually convert the binoculars into white light binoculars. So there's your exception to that. Putting the white light filter on the front of the scope. The Herschel wedge. Using a aperture mask inside on the end of the scope. I actually have an aperture mask here. I have an aperture mask here that I made for my traveling Dobsonian. I've got a 12-inch Dobsonian that you can pack into a little suitcase size and put it on as a carry-on. But what I have here is I've got 3 different apertures, depending on your seeing, and it's using the Bada white light filter. So pretty cool doodad. If the seeing's not good with the bigger aperture, you can dial it down to a smaller aperture, and it really helps the image. This right here kills me. I don't know where this guy is, but seeing is not his friend. And, unless he's on like a mountaintop somewhere or maybe an island, then he'd be all right with this. I can't even imagine what he's seeing in there. It's probably pretty messy, though. Next slide. So there are other filters besides hydrogen alpha. This is kind of the next step up. This is kind of in the realm of, almost to the realm of hydrogen alpha filters. So we've got singly ionized magnesium B2 line. We've got, and that's, what did I say? That was the mesosphere and the upper photosphere. The calcium H line, calcium K line. You've got the helium D3 line, which is going to be lower chromosphere. And you got the sodium D line. I can't remember where that is. But anyway, next slide. So, Bob Yosley. This is a guy that he's quite the expert. He's an amateur, but he's definitely somebody that I consider in extremely high regard as knowing what they're talking about when it comes to solar astronomy. And this is what he said. And this is kind of what I was talking about in the very beginning with the fact that this is a dynamic. You can actually sit, and if you take the time, you can watch prominences change color or change shape. I've sat and watched a prominence basically follow the magnetic lines and actually grow, and the magnetic lines are pulling the matter up. And you're actually seeing this in real time. It's slow, but you're seeing it, and you're seeing it change. It's very cool. So what's in the back here is actually the solar telescope in Hawaii. I don't know if you got to see that, but it's really cool. Anyway, so each one of these, this is the granulation. This is actually the top of the convection cells coming up from the inside of the sun. And each one of these, where's my laser? There you are. Each one of these right here is about the size of Texas. Next slide. So, hydrogen alpha, that's the holy grail. What's the big deal about it? So, a nanometer is a billionth of a meter, okay? A sheet of paper is about 100,000 nanometers thick. An angstrom is 1/10 of a nanometer. So, the hydrogen alpha emission is actually visually invisible. And so with visual hydrogen alpha filters, they don't exist. So the closest thing you've got is called an ultra high contrast filter, UHC filter. And that has, that transmits oxygen, and I think some nitrogen, and hydrogen beta, but you're not getting hydrogen alpha because the eye can't see it. It's a very weak signal, and with the sun, absolutely not without serious filtration. We're going to get into that here. So your visual UHC is about 8 to 10 nanometers in bandwidth as far as what part of the spectrum that it's catching. Photographic hydrogen alpha filters, they get a little more narrower, as narrow as 3 nanometers that you're using for astrophotography. Solar hydrogen alpha filters are pretty much between, 0.07 nanometers at bandwidth at widest. So that's 0.7 angstroms to 0.2 angstroms. 0.2 angstroms, it's extraordinarily narrow, and there's a cost to that, and that's something that you'll see in a second. So this is how an etalon works. So the etalon is the actual solar filter for hydrogen alpha, and you've got 2 pieces of glass, and you've got something in between that affects refraction. So when you've got sunlight comes through, or not, an energy rejection filter, the light is entering into the etalon, and then the etalon, by its capability of refracting the light, is basically splitting the sunlight frequency centered on the hydrogen alpha band into a comb-like signal here. So you've got several that are off band here, and then you've got the one hydrogen alpha, this slice right here, 656.8, 656.4, whatever it is, but it's the hydrogen alpha band, and once it comes out of the etalon, you've got this comb, and then you've got a secondary thing called a blocking filter that takes the hydrogen alpha tooth of the comb and transmits that through. So there's a great deal of serious filtration going on here. And this is kind of another, actually Bob Yosley drew this, but this is kind of another where the curve here basically represents the bandwidth of the light. Next slide. So you've got this Etalon. In this case, it's a pressure tuned Etalon. So basically the air pressure between these two glasses, these two very thin, very, very close together pieces of glass, are basically being affected by the air in between them. The thickness of the air is your lens, and that's what's creating the comb of the light that filters down through it. So here, with no pressure in it, and this is an Etalon. Careful, careful. This is a big one, but this is a pressure-tuned Etalon. That knob right there, you turn it, and you can increase the pressure or decrease the pressure. Easy. Good boy. So, no pressure. You're basically looking at the red side of the hydrogen alpha line. Next slide. About halfway through this, about 2.5 psi, you're right on, 656.28. Look at there. Oh, I was off on both counts. Anyway, you're centered right on hydrogen alpha. This is where you get the really sweet view right here. Okay, it's centered on the. This is tuned to the hydrogen alpha band. Okay, so next slide. So if you screw it in even more, then you're going to the blue side of the hydrogen alpha line, and you're starting to see some of the photosphere. So the thing is that having it, the capability of being able to tune it on and off of the actual hydrogen alpha band is enabling you to see different altitudes of the solar atmosphere. That's the deal. And when you actually get on band, you're seeing the really magical stuff going on with what the magnetic fields are doing with all this matter. So, next slide. So you've got two types of Etalons. You've got solid-spaced Etalons, these solid-space ones. That means that in between the two pieces of glass, there is an extremely thin slice of mica. And when that mica heats up, it expands, and it pushes the two pieces of glass apart. Now, these can be really expensive, and the bigger aperture, the bigger clear aperture you get in these Etalons, you're actually really, really going up in cost, because imagine doing paper, thinner than paper thin slice of mica and trying to get it in a big piece like that. It's an extremely difficult and expensive process. So you've got the Daystar Quantum. Daystar is a big brand, Solar Spectrum, the Daystar Quark. So next slide. So the Daystar Quantum and the Solar Spectrum, they're both really high end there, okay? And you're looking it up to research grade stuff, okay? Now, you take all that stuff and you set it aside. This guy right here, I say $12.95 specifically because it's been this way for a long time. I just set this price here. This is a great entry-level, value-priced for hydrogen alpha. If you drop $1,300, this gets you into the hydrogen alpha world, and it's a really great entry point if you're wanting to get into HA. Next slide. So then you've got your air-spaced Etalons, okay? So you've got Lunt pressure tuned, like the one that I've got here. You've got Coronado Rich View, which is basically tuned by a little knob, where it's actually mechanically adjusting the different distance between the two pieces of glass. And then you've got a tilt tuned, which uses similar kind of knob, except you're tilting the glass relative to each other instead of spreading it apart. Next slide. So the Etalons are, you're talking about getting into, like $2,000, $3,600. You can get a red background glow with it, but I don't find it annoying, and that's the kind of telescope I've got here. The Coronado, based on the size of the clear aperture, 800 to 3300. It's hard to reach if it's front mounted. If you've got a long telescope, you know, how do you turn that? God, that knob is just right out of reach. And so they've got some remote things, but it can be a pain. It's the same thing with the tilt-tuned when you have it front mounted. And both of these guys can actually create ghost images in the view because you're messing with the glass in a way that's mechanical. The pressure tune is actually the cleanest that I've seen. Multiple placement locations. It can be on the front of the telescope. It can be inside the telescope, in line in the optical path, or it can be on the back end of the telescope. Next slide. So the blocking filter, this is absolutely required for air-spaced etalons, okay? You cannot look through one of these etalons at the sun or have it on the end of a telescope and be okay with that. You've got to have a blocking filter, and this is a blocking filter. They come in different clear apertures, and they come in different bandwidths. This guy right here is actually for calcium K-line. You don't need an etalon for it. You wouldn't be able to see anything if you had an etalon in front of it because the etalon is putting out a different bandwidth. This is in the 300, this is in your lower range of the spectrum, so that's on its own. There's the one that I've got. The Daystar etalon, it actually has, this is a raw form of it. Next slide here. If you get one like this, you want to send it back. This is the inside of it before it actually gets manufactured and goes into its case. But it actually has the blocking filter inside of the etalon package. Solid space, they've got the blocking filter built in, like I said. Coronado PSTs, which we'll get into in a little bit, they've got the blocking filter built into the scope. Let's see. Non-pass-through blocking filters. Oh, yeah. So it's your diagonal. So the blocking filter, if it's not a pass-through, because you can have pass-through, but that's pretty much for like imaging, that this is a blocking filter, that it's a diagonal. So you've already got your comfort as far as the angle at which you're looking through the telescope. And then, of course, like I said, the CAK line is standalone for LUNT, doesn't require an etalon. Next slide. So double stacking is actually the next level. So you can actually have 2 and even 3 etalons. It's kind of ridiculous with 3, but you can have 2 etalons, and here's the difference between those 2. So there's your this black line right here is actually the absorption line for the hydrogen alpha. And then center right here is basically your transmission. And you've got, you know, a 7.7 angstrom single stack. And look what the double stack does just by dropping it down a couple of 0.5 angstroms is you start getting some serious detail because you're increasing contrast. Next slide. Etalon comparison. The air-spaced, there's no power required. Instant band adjustment. It requires a blocking filter. The specs are consistent, and double stacking is possible. Solid space, and this is why I didn't personally get solid spaced. I wanted to spend the money for air spaced, but if you got a cork, you know, and that's where your budget's at, then that puts you in a position to get into hydrogen alpha at a pretty decent price, relatively speaking. Problem is, power is required. The band adjustment takes time because you're waiting for the mica to heat up. So you can have like 5 to 10 minutes waiting for your adjustment to get on band. The blocking filter is built in. Consistent specs are possible, but you're paying for it. Double stacking is discouraged, and it requires a long focal length, like up into f30 and f40. Next slide. DIY. This is what I almost did before I bought this thing. You don't need a triplet. You can use a doublet, but I was looking at an F8 because with a Daystar Quantum, or, next slide, a Daystar Quark, that basically they've got, you know, with the Quark, you've actually got the telecentric actually built into it. So 8 times 4, that'd be an F32 system at the end of the day. So that's kind of your second iteration of that. Next slide. Dedicated hydrogen alpha telescopes. So you've got Daystar Solar Scout. They're solar ready. This beautiful black and gold piece of art right here. The Solar Max. The Coronado PST. Cy Simonson brought his for you guys to check out. And you've got your Luntz THA, which is a variation on this. And you've got your Airy Lab. And next slide. The problem with the Airy Lab is that unless you're on an island or in space or on a mountain, you know, it's too big of an aperture. This is the pricing that's basically happening here. If you want to enter into hydrogen alpha, but you're not wanting to spend $1,300 on a Quark, $900 gets you into one of these Coronado PSTs. And they're really great. I've looked through them, and they actually produce a really great image. Broad range of apertures with the Lunt. The Solar Max basically goes up to 90. The Lunt gets bigger. The Solar Scout is not bad. It's a dedicated telescope, and it's got a Quark built into it. The Solar Ready's got a quantum built into it, hence the price. $10,000. Next slide. Other dedicated HA telescopes by Lunt. This is nothing that any of us want to spend money on, but like they you know, I was actually thinking about getting a 152, and the Lunt guy was like, "Don't do it. If you're not living on an island or on a mountaintop, you're not going to enjoy this as much as you just would get with something smaller." So I got a 130. They make a 230 and they make a 300 for the low price of $84,000. They have this on display at NEAF every year, and it's from the end of this, it's like 6 feet long, and it's just like, really, are you just showing off at this point? You know, I consider it not even practical. Next slide. Next slide. Hybrid. So Lunt makes the Universal Series, and that's what this guy is. The cool thing about this guy, or any of the smaller versions of this, is that it comes with something. This is a different focus back on it. You can actually convert a hydrogen alpha solar scope into a nighttime telescope. So now we're talking about a versatility here. And now I've got 2 scopes in one. Next slide. It's available in multiple sizes, completely modular. Finders built into the handle. It's an apochromatic, so you've actually got some quality optics for the nighttime use. And it totally converts. The only problem is it's a little heavy. This double stacked is 40-pound telescope. So there's that. That's why it's in red. See the red? Next slide. Solar accessories, and we're wrapping this up. Solar accessories. So you've got the energy reflection, I've been screwing this up the whole night. Rejection ERF, and you've got binoviewers, you've got a zoom eyepiece, you've got the solar finder, and this is actually something that I built inspired by Robert Sirkis building his, is a tripod dolly. So next slide. So in yellow, these are the prices on these guys. The binoviewers I consider to be an absolute must-have. Looking at the sun with both eyes, stereo vision, you're getting rid of the floaties, you're increasing contrast, which is a big box to check. and you're actually getting a better depth of field. Remember, the sun is almost a million miles in diameter, so you get actually a great deal of depth of field when you're looking at the disk. I'm not going to go into any of this, but you know, a sun finder, you basically can't just use a finder scope looking at the sun, so it's basically a reverse pinhole projection so that you can see that you're actually centered on the sun. Next slide. More solar accessories. I've got one here. This actually wraps around the front of the scope. It's closed by Velcro. It's a shroud. It's a great thing to be in shade. It's the only downside of the solar astronomy is the fact that you're in the sun. A shade tent. I also got this, a mini fan. So, you know, blow on me while I'm, and then there's like a sunshade. Basically, you're taking a doodad like this. Thank you, Cy. You're taking a doodad like this, and you're sticking it on the end of your telescope. Next slide. This is the pricing here, and it's just they're just really handy things to have in my experience that I've found thus far. Next slide. A necessary endorsement. So this guy right here is my Dinkmeyer Binotron 27, and it is an amazing piece of kit right here. This is very well engineered, and it's got a 1.3. You can actually slide these little things right here, and you're actually getting 1.3, 2.3, and 3 magnification. You've got to have 2 eyepieces for them, but you're getting stereo vision, and you are getting basically 3 sets of eyepieces out of 1. And it increases contrast. When it comes to the sun, it really makes 0.6 angstroms look more like 0.45. Not bad. And then it can be used in the nighttime too, and it's got a little, it's got a filter slider, so you can actually move in filters. Next slide. Electronic Assisted Astronomy, EAA, you've probably heard of it. Mr. Man here, Michael Tier's getting into that. You can do this with any telescope. It's certainly a great method when it comes to outreach, to be able to display it on a monitor, to be able to get away from the telescope. Monitor can be inside a shaded area. Is definitely able to brighten the dimmer signal of double stacking. Next slide. What I didn't cover, all this stuff. Solar astronomy is a huge, huge subject. Next slide. Solar Chat. It's basically the cloudy nights of solar astronomy. SolarChatForum.com. Solar Astronomy, this book, Christian Valedrich and Bob Yosley were involved in it. This is a textbook. Everything you want to know about solar astronomy, everything that I've talked about here and everything I didn't talk about here is in this book. This is a compendium of solar astronomy. I highly recommend it. NASA's Heliopedia, very cool website for all sorts on solar. Next slide. More learning resources. BADA's AstroSolar site, astrosolar.com, is absolutely the full spectrum, pardon the pun, for white light astronomy. Literally anything that Christian Valedrich or Bob Yosley says I consider as gospel. And last but not least, the people in this club that are into solar astronomy, we all help each other, and that's what it's all about. Next slide. So, find a way to look at the sun. Thank you. It was a long one, I know. There's a lot to cover. Thank you for your patience.
Thanks, Bill. Okay, so we're a little bit behind, so we'll take a 7-minute break. We'll do the raffle, then we'll do Bill's then we'll get into the rest of it. 7-minute break.
I'm here to answer any questions you got about any of the hardware, toys up here at the front.
Awesome.
Yeah, look at me.
That's okay.
20 past 55, I was like, okay.
How long is your, what's the founding?
It's a portable dressing room. It's like one of those pop-up things. It's like and like, it's perfect. It's outside and you basically sit in the tent. It's a portable dressing room. It's like a beach dressing room.
How do you support this?
I should have, if I should have brought my day. I have a day store cord. I could have brought it. I'll have to. I'll go through my quandrums on using it and stuff. It's the 4X, the built-in 4X bar load doesn't help.
So how do you support this in the
Okay, so you guys both. Can you guys both do? You guys both do the World of Beers?
No, I
I am.
Yes. Okay.
I don't know. I had,
I'll get some food.
So basically, bam.
but it'll support that, okay.
You have to have a.
Sure.
I don't want to.
Yeah.
Yeah, thank you. So you do that. I got it. Do that, and
A lot of weight on it.
That's pretty cool. That's adjustable back there.
so that, that's pressure release. So, yeah, so that's air pressure. That's air pressure on the inside.
I was reading the one, it said something about the warranty void dropping.
Well, first of all, don't drop it.
Well, yeah.
The thing is, we're talking very thin pieces of glass that's very close to each other. They can if it's been under shock, they can.
Robert Cargill here?
No.
Okay. Probably I don't know if I ever met him. Late after the talk, I need to. Thank you. I'm about to get by here.
Oh, congratulations on making it rain. Finally. Yeah.
Hey Bob, are you an SIR Pro user or?
Yeah, I have, yeah. I moved off the Nina, but I do have the
or the plus. You don't have to, I guess it all works off the same
It's the
thing.
same, yeah.
Do you ever use the app on a tablet or anything, or is it just through the computer?
I have a tablet.
Okay. I just got one, and I got an ASI 224MC. I was messing around with it for the first time last night, and I was like, I need some help.
Yeah, we can sell it sometime. It's pretty easy. One of the drawbacks is they don't, no one says.
Well, first off, I was using it, I don't know if I got the backspace right or anything, but I was using it through my 9 1/4 inch Smith catheter. That may be old.
What does that got to do with front time?
So,
It runs a camera in the mouth.
I did see the moon. It was zoomed in a whole lot because of the focal length. And I can never get it focused just right, but there could just been a lot of atmosphere. And
Yeah, well, with the moon, there's, there's two types of focusing.
right.
There's one's contrast with HFR. And so you want to use a contrast focus.
And I try to look at Saturn. I could not get it focused or do anything.
You have the obviously you have the EAF.
Yeah. Well, I've got the Celestron EAF, which I have to do manually.
Yeah, because it won't.
Yeah.
And if you have the ZWEF, ZWOEAF, upgraded
Yes. All right.
Okay. This is one of my favorite parts because sometimes I get to use the word disqualified. Five tonight, guys. Four 480-7979. 480-7979. Oh. And we have a winner. Hang on a second. Absolutely. This is my optician's test. You're good.
Welcome back, by the way. I was wondering if you were coming back.
All right. You're welcome. Thank you. 480-8031. 480-8031. You won last month. Disqualified. Four 480-7998. There we go. We have winner, winner, chicken dinner. Yes, sir.
And stop. Don't go any further left.
480-8041. 48, oh, Mr. Haggard. Pardon? 48080, yep. 480-7987. All right, that's, encourage you to join. Yeah, awesome. And last but not least, yeah. 480-8016. He's picked up his prize. 480-8016. Board members disqualified. No, I'm just kidding. There you go. Thank you guys very much for participating.
Easy.
Here you go,
Easy.
Cy won't mind.
Easy. All right. Oh, no. Hope y'all like my voice because you're going to hear more of it. All right, so this is what's going on in the sky from now until the next meeting. And what we've got here is Chris's Chris's Mlanicki. Sorry. Chris M. Yeah, this is his effort with hydrogen alpha solar, and it's magnificent. Next slide. All right, we have Neptune in opposition. This is tonight. It'll be closest to Earth because the sun is on the other side of us from it. And yeah, if you've not seen Neptune through an eyepiece, it's a little blue disk. And if you've got a big enough telescope, you can see Triton, its biggest moon. Next slide. You won't look like that, though. Disclaimer. Bright comets in September and October, magnitude 10 and higher. Well, Nishimura's comet is getting to perihelion, which means that it's really close to the sun and actually going down, not visible until November. It may be magnitude 4.1, but if you can't see it, it doesn't matter, so I marked it out. Periodic Comet 103 Hartley, magnitude 7.5 in Auriga. Inky, I wait for this comet every time it comes around. It's like 3.5 years or something like that. This is the second comet after Halley that was discovered to be a periodic comet. 7.5 magnitude in Cancer. And then Comet 2020 V2 is just underneath magnitude 10 in Fornax. And this is actually my image of 2022 E3 ZTF with the stars removed. I did a close-up shot of that. It's pretty cool. Next slide. Occultations and close approaches. So I fact-checked myself. I got my minutes and my degrees straight. Thursday, September 24th at 2 in the morning, the moon occults Antares again. It did this last month. It's doing it again. Tuesday, October 3rd in the afternoon. I'm going to say that's at night. Yeah, it's probably at night. I wouldn't have put that in. Dang it! 3:21 a.m., the moon and the Pleiades are just slightly less than a degree apart. Moving on. Mercury in the morning. We've got the greatest western elongation for Mercury on Friday, September 22nd. The highest that it will be by civil twilight is about 11.5 degrees above the horizon. So not very high, but that's what you get. Next slide. So we got fall equinox coming up on 23rd, And then the nights start getting longer and longer. Hopefully cooler. Next slide. All right, so our least favorite moon phase is on Saturday the 29th of September, but it's just right around the corner, 2 weeks perhaps, that the sun is going to come along and they have their show. Next slide. The Draconids meteor shower is on Friday, October 8th into the morning of the 9th. It's 21P is the Geiger is the comet that it's born from. It peaks in the evening because the radiance so high. This is actually unusual for a meteor shower that actually peaks in the evening. It's usually, yes? Did I do it again? I'm better than last month, though. I was a wreck last month. Thank you, fact checker. Anyway, no, it is 8th and 9th. So day of the week, ignore the day of the week. It is the into the morning of October 9th. Yeah, and maybe you want to fact check that too, now that the doubt is here. I actually went out in 2018 to about halfway to Abilene, parked on the side of I-20, and it was as good of a meteor shower as a decent car seats. So sometimes these things can actually show up here. Next slide. The new moon is on Saturday, October 14th. And I guess that's it. No? Am I missing something? Am I leaving something out? Next slide. Oh, it's the solar eclipse. Okay. Yeah.
Who's dead?
So, same day as the new moon, incidentally, is our last U.S. annular solar eclipse until 2039, and that one's in Alaska. So it's handy, it's local, be a part of it, go see it, make the time and do it. This is the pathway. This is really cool. This is, where is it? Where's my laser? Where's my laser? Laser. I don't know where my laser is. Here's my laser. This is a neat thing. If you've ever been curious about the whole, curve thing, this is basically
driver's license is a
the
fake.
whole
That's
idea
changing price, take a look at here, but
with the
Fort
curve
Worth
here
Astronomical
is the
Society.
fact that it's the pathway is moving in a straight line, but because of the curvature of the Earth, it's doing this curve thing. It's kind of a Coriolis effect sort of thing.
I don't think so.
Not. I just thought it was neat. Next slide. So this is the solar
that's
eclipse
her.
over Texas. This is at
Kurt, can you mute, please?
GreatAmericanEclipse.com, which is a great resource for this eclipse.
Hang on just a second. They're
And
talking about the October
it
eclipse.
shows, there's actually another one that flies over the whole country as you're following the shadow. And it was too long to do here, but it's really cool. But it gives you an idea of where to be for that. And of course, ideally, you want to be close to the center line. Next slide. Okay, so you've got GreatAmericanEclipse.com. You've got TimeAndDate.com. EclipseWise.com is a great site, and so is EclipseOfFile.com. These are 4 fantastic resources. Weather patterns, historical cloudiness, likelihood, probability of cloudiness in
You
any
what?
given location. Fantastic resources. Next slide. So this is, it's an annular solar eclipse, but it's phobos, as seen from Perseverance. Handily, it just happened to be in the pathway of the shadow. Perseverance did. I looked and looked to see if there was maybe a purposefulness of where Perseverance landed to catch this, and I didn't see anything. This could have just been chance. Anyway, next slide. So I'm going to cut this short, and as a joke, I was going to say, well, we're going to feature Sagitta, which is about the most, you'd think the most featureless constellation in the sky, because it's a little arrow. It's like made up of like 4 stars, and it's the one that everybody forgets about. And then I looked up, it's like, holy cow, there's like a lot of stuff in there. So I'm going to feature this next year when it comes back around. So it's not really much of a joke anymore. Next slide. And this is Robert Sirkis's Bubble Nebula in Hubble Palette. And keep looking up. Thanks a lot.
Thank you, Bill. Cover your eyes, everybody. Okay, so I'm going to try and pick up the pace so we get out of here before 10 o'clock. Now we're going to kind of get into the business part of the meeting. We're going to talk about outreach, and Patrick is going to talk to us about what's going on generally, and then Pam is going to talk to us about Tandy Hills.
Okay, so we're at that time of the year again where we're into star party season. Can you read that? Okay. Yep. All right, so here we go. Just got a few right now. We got one Friday. I'll post these all in the e-group. A couple of Cub Scouts. Got one up in Irving there. And then, of course, I know everybody's going to be busy with the solar eclipse, but I do have one event down in Dalworthington Gardens in Arlington. I'm going to do that. If anybody wants to help out, let me know. But that's on the 14th. And because we have that on our Night Sky Network, we're actually going to get some eclipse material from them. So that was kind of nice of them to do. And then the same night as the same day as the eclipse, we have our monthly Dinosaur Valley Star Party. Again, I'll put these all on the e-group as we get there. And also this Saturday, Juan is going to be helping out with 3 schools in Fort Worth. He's going to do a little eclipse presentation, planning, and kind of instruct them how to view and how to handle it. And he'll post that on e-group later. Thank you.
Pam is going to cover Tandy Hills for us.
This coming Saturday night is going to be our next star party at Tandy Hills, and John has already sent out the information on that. We did not have one in August. It was just too hot, and then it turned out it happened to be cloudy that night. So for those members who might be newer to the club, we hold this star party March through November, weather permitting. And we have a very dedicated core group of club members who support this event. We have maybe 12 or so club members who come out with their telescopes. And we have maybe anywhere from 40 to 60 folks who come through and look in our scopes and enjoy what they see. So if you are newer to the club, or if you don't have a telescope yet, this is a good time to come on out and see what telescopes we have and to enjoy the evening. So we will see everyone Saturday night.
Thank you, Pam. Michelle?
All right. Rising Star Observing Area, the Development Committee did meet the first Thursday of the month is when we're getting together via Zoom, or actually Google is what we're doing it on. And I will let Bruce talk about some of the current projects going on because he's been more involved as the person out there. As a rundown, we currently have the fence work in progress. Again, Bruce will give us more detail. Our group has decided, as we discussed it, that after we finish with the fence project, we will be moving on to the storage unit for the property. And one of the reasons we're definitely looking at that as a next project is because it will help us alleviate our monthly storage payment and so save us money. One thing about this, though, is once we've got our fence project done, some of our observing field development money fund will be depleted, and so any donations will be very much appreciated. You can always let John know exactly where you want that money to go. If you want it to go directly towards helping us at Rising Star, helping us get that storage container going, or the storage building, then we can go ahead and start building our fund so that we can get that project underway. Our group, the development committee, is currently discussing the container versus getting a building, whether we want to do it turnkey, have everything done for us, or if we want to do it yourself, like we did with our smaller shed for the toilet. We are looking at a use that will accommodate storage of telescopes, storage of maintenance equipment in a separate area so that all of that will be protected, and then at least a small area where a few people can set up cots and sleep overnight if that's a place you want to shelter in. I'm going to let Bruce talk about the current project going on out there.
Okay, very good, thank you. So I just wanted to highlight the fence project that's going on. They mobilized yesterday, and I guess what they actually did was they moved us up in the schedule by about 6 weeks. So good news for us. And they mobilized yesterday, and then they cleared the property line, so we have clear line of sights where the fence is going to go. It'll also be a place that we can maintain, so we keep our fence in healthy order for its lifetime. The fence is an investment, and we're going to do our best to maintain it throughout the years, so it'll provide us a lifetime of, I don't want to say security because it's a 5-strand barbed wire fence, but it's a fence, so it's our side of the property, and it will be in good shape. What I will do is I'll send pictures out through the e-group on the progress that's been made, especially when the fence project's done. So that's all I have for today.
One question.
Yes?
What's the latest on dry grass fire conditions out there right now?
We're still in a burn ban. I checked earlier this month. I haven't checked recently, but the burn ban expires, I believe, sometime in October, unless the judges reverse their judgment. There you go.
It's actually the commissioner's court.
Right. But right now, it's still a burn ban. It's still pretty dry out there. That area got anywhere between 3 and 4 inches of rain this past week, so it was well needed. I'm not sure our property got 3 or 4 inches, but they did get some. Right. No, I was out there today. We have sandy soil, and it's damp, but we didn't. I couldn't find any locations where we had standing water.
Generally speaking, it drains pretty well out there, pretty quickly. I asked Tom Roth, he has nothing to report on Palo Pinto today, and I have a few announcements to make. The Christmas party is presently scheduled for December the 9th. I'm looking to move that to December the 2nd. I'll see if I can't do that this week, and that's a purely selfish reason. I won't be able to attend. So, excuse me. The new moon in March, just as mark your calendar, that's when we're planning on doing our annual open house in Messier Marathon.
Okay.
The new moon in March.
Stay tuned for my presentation.
Yeah.
In March.
And then another big item in November, the November meeting, of course, is our annual SWAT meet. And the APSIG group is starting a project. We're actually probably going to start the imaging in October. There'll be, the group of us will settle on an object, and we're going to attempt to collect 100 to 200 hours worth of data, work together, and submit it to NASA and some other folks to see if we can get some recognition. It'll be a great opportunity to go out to Rising Star, because we're going to do some work out there, and if you're interested in astrophotography, that'd be a great time to start your knowledge trail. And there's no website update other than we're targeting mid to end of October to go live. And Juan Martinez has, from the Eclipse team, has some things to say for it, mentioned to us.
All right, you've carved out a full 30 seconds for me. Appreciate that. So just the short version, we've already been starting to receive a lot of outreach requests from around the Metroplex. And of course, we just don't have the resources to host at every single venue. As Patrick alluded to, we're decided to kind of meet folks halfway. Regarding the Fort Worth ISD, we're having I started calling it a teacher training seminar, more of an info session, hosted this Saturday at Kirkpatrick Middle School, plug to them. A few of the directors have been invited, so I'm sure word will spread like wildfire, and we're getting the excitement going. If not for the annular, at least we'll be in position for the total eclipse of April 2024. Let's see what else. Chris and I, if you recall, as part of the extension of the Solar System Ambassadors Program, as part of the Eclipse Ambassadors Program, we've been teamed up with a cohort from a couple of reservists that are undergrad students. They're planning to host, on the day of the eclipse, on October 14th, a session at the JRB Naval Air Station. So pretty proud. They're really excited to help us mobilize them for that effort. Chris, do you have any clue what head count they're expecting on that? Let's see, what else? For all the guests, visitors, members already know, come back to the back if you haven't scored your swag. We got some free Eclipse glasses and some Thousand Oaks solar film available. We'll make that available to guests and visitors as a bribe to show y'all how addicting astronomy can be. And thanks to Bill, who has showcased all of these goodies. Word of caution, every time I talk to my astro buddies, I seem to lose $500 to $1,000. An extended invitation, check our website, the calendar, this Saturday, as Pam mentioned, at Tandy Hills. I'm sure we'll be expositioning a lot of these toys and goodies if you'd like to see them in action. Chris. Yes. Stay tuned. Keep monitoring our YouTube channel. Chris has been producing really informative and really cool series of videos, safety videos for the eclipse. And currently we're planning to be down in San Antonio Hill Country area. Chris is planning to live stream that. So wherever you happen to be, compare notes with what you see out in the sky and online. Question, say. Yes. In addition to the eclipse glasses and solar film, we do have free the rear projection film. And pro tip, Harbor Freight. Get you some of these funnels. I think they're about $4. And if you really want to go against the grain, get you one of those welding helmets. Those are the highlights. Bob, back to you. Yes, right. I think that's it for now. If anyone is willing to host an event near your local region, Arlington, Keller, Northside, Eastside, reach out to myself or some of the Eclipse team with Patrick and the outreach. I'm sure they'd love, and we would love, to have you represent us. That's it for now. Stay tuned. Be watching the E-group. And clear skies, clear and sunny skies.
And if you have opportunity to look at Chris's YouTubes, they are more than outstanding. They're pretty awesome. So, I'm heading that way right now. Mr. John Giramini's been, our treasurer's been waiting patiently, so.
pull it up then, doesn't it? I have to pull it up so I can read it. I can't read it from back here. Yes, we have that money. Just so everybody knows, there was some person mentioned giving donations to us. We basically have two funds that we keep track of. One is what we call the general fund, which is where membership dues, picnics, blah, 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 blah. Insurance coverage, various and sundry things. The other one, all the other projects, all the other things, the acquisition of assets such as property, equipment, buildings, that's all in the project funds. So if you would like to donate, you can certainly provide that via Zelle or check or cash. I wouldn't prefer the cash, but you could do that. And say you want to put it toward the projects, and that will show up in that $11,000 area. It's George on Zoom?
No.
No?
No.
This has really been a pretty cool thing George has done for a number of years. And Verizon, as a corporation, provides an incentive for people to do volunteer hours for various organizations. And our organization qualifies for that. And so he submits his hours, and Verizon pays us $750. So you might look and see if whomever you work for has a similar situation. Right now, we were sitting at 100 and, you want to scroll up a little bit for me? Or scroll down, sorry. Right there. Right now, we're sitting at 181. And if the other person comes through, we'll be at 182 tonight. So we're progressing forward with Viga. Next up, there you go. Those are the people we talked about already. And up to the membership item there. I've referred to this, that little hitch there on the right, I've referred to that as a cliff. And what happens is we do renewals every year. Those who have been here before know that. The new members will hear about it. And of course, as with anybody in an organization, you lose people. We were losing quite a few in past years. This last year, though, was really nice. We ended up keeping most of our members, a lot of our members. So that's where we're at right now. Next, and I think that's it. Yes, that is it.
Thank you, John. So, two things left. What if I don't want to be on the damn camera? Yeah, I know. Okay, so we are in the process of raising money for an observatory. Been working with someone who's volunteering to help with the grant process. We've narrowed down to 5 potential grantors. I've had a conversation with one of them based here in Dallas, actually, and a very good conversation with them. So that's in progress. Once we submit the paperwork, then we'll announce who we're going to grants. I just wanted to point out one other thing. I work for Transamerica, and they have a program where they match dollar for dollar up to $2,500 if an employee makes donations to 501c3s. So They do that through a group called Giving Tracks. I'm getting ourselves on Giving Tracks. That's another opportunity for those who are that may work for companies that have that kind of program. I think it's really cool of my company to do that, and if you're so inclined, might be something to look into. And then we are going to create a committee. I'm going to ask Cy to chat about it for a moment. We're going to create a committee with 5 members, 2 board members, and 3 at-large members to review the bylaws. They do need some work. Thanks.
Yeah, so when I reviewed them last year, I was just looking at stuff mainly focused on getting us a tax exemption for the property. So we want to relook at the whole bylaws, see if there's a couple things we want to change. I know one right off the bat. Our committees are only for 2 years. They're supposed to change. I think that should be extended, because Palo Pinto Mountain and Rising Star, we don't want to lose all that expertise by kicking you off your committee every 2 years. So anyway, if you want to volunteer, I'll put something out in the e-group. Let me know if you want to be part of that. And we'd like to have some meetings via Zoom and try and get that done before January and vote.
Thank you. Anybody have Anybody have any announcements to make? Oh, Bill Hall. He's giving away his universal.
I think you're going to hear the enemy. So if you guys are familiar with an author and moon expert named Robert Reeves, it appears that he is going to be our guest next month. So we have a little sun-moon theme going on, so stay tuned.
Thank you. Anybody would like to make announcements or have anything they would want to chit-chat about? No. Door Dream, maybe. Well, with that, then I will make a motion that we close the meeting. Thank you very much, everybody. See you next month or at the World of Beer.